Hi, today we are going to use YOLOv8 for card detection. So we will download the dataset that contains all the annotations, create a model, run the training, and then we will take a test and fresh image and run the model over this image. So you can see an example in this video. We are taking a simple image and run our model. On the left corner is the prediction, on the right corner is the ground truth. As you can see, it's a perfect model that detects well all the cards in our image. You can watch more object detection tutorials in this playlist. So let's first start with the installation. So the first part, as always, is the installation. Here is a link for another video that contains also a detailed process of all the YOLOv8 installation, but as a brief we can cover it now. As you can see, we are creating a new conda environment named YOLOv8 and then activating this environment. Then we running this command that will reveal our CUDA version. As you can see, I'm using 11.8, and this is the command in order to install the PyTorch 2.1.1 that support CUDA 11.8. As I mentioned earlier in my previous video, I covered all the process how to choose the relevant PyTorch version, and at last we are installing the YOLOv8. I chose for this tutorial to install 8.1.0. So this is the installation part, and now let's download our dataset. So here is the link for our card dataset. Let's go for this website, and as you can see, we will use the RoboFlow website that contains many datasets, and we would like to download this card detection dataset. If I go for this tab named images, you can see many images, thousands of images. Let's go for this one, the first image, and as you can see, all these rectangles are annotations of the cards, and you can see here on the left side, this one is for 3S, and this one is 5C, and this one is 8C. C is the symbol, and here the S is this symbol of a black heart. And if we choose another image, once again you can see the annotation for each of those images, and here are the classes. So all these images are already annotated. Someone did all the hard work, and if we go for here for the dataset, we can see that the dataset is divided for 21,000 trained images and 2,020 validation images and about 1,000 test images. And also, if you would like to know all the classes, we can go for the overview, here for the images here, and if we pick these classes, we can see all the relevant classes for all those images. So let's download this dataset. Let's go once again to this dataset, and since we are going to use the YOLOv8, let's choose here YOLOv8, and we would like to choose this option, download zip to our computer. Click continue, and done. And as you can see here, all the process is started. It says one download in progress, and let's wait a few more seconds until the download is ended, and we will extract this zip and see all the images inside it. So after extracting the zip, it created a new folder named plain cards with all these full suffix, Let's shorten this name. Let's name it plain cards. Great. Okay, let's go inside, and as you can see, we have a structure that contains a data.yaml file, and then we have three subfolders: train, validation, and test. Let's first open this data.yaml file, and what we can learn from here that we have to point the full path for our train images, validation images, and test images. So let's first of all copy the full path. So we will copy this path to here. So this is for the train images. Let's fix the directions of the slashes, and we also need to copy this for the validation. So we will copy and change here to valid, and let's also copy here and change this to test. Great. Next, as you can see, is this part. We have 52 different categories. So basically we are going to train and then detect 52 types of images. So these are basically the cards. So this, for example, is a 10C, and then a 10D, and C and D and H are the symbols. So as you can see, these are all the 52 types of cards that we are going to train and then test and detect. So we do all the changes. Let's do a save and close it. Now let's go back to our subfolder and let's see what we have here. Okay, so as I mentioned earlier, we have a train, validation, and test. Let's see, inside test we have images and labels. How many images? Let's see here. As you can see, we have 21,000 images. A lot of images we are going to train. And then let's go inside this folder. As you can see, this is, for example, the first image. Let's open this image, and if we go back and go to the labels folder and we go for the first label, the first label has the same name as our image. So in this image, on the left side we have our image, and on the right side we have our labels or annotations. And as you can see, we have one annotation named categories number 32, and these are the points that describe a rectangle around this relevant annotation. And we have one category is 5 and two categories named 28. So since we have this 8 number card, we can probably assume that this 28 is describe this side of the image, and the other 28 describe this side of the image, and these two can be category 5 and this one can be category 32. Let's, for example, open back our data label, data YAML, sorry, let's open the data YAML. And if we go to the data YAML and let's try to understand what is category 5. So this is 1, basically it's 0, 1, 2, 3, 4, 5. So this 2D is probably this one. 2, and D probably is the diamond. So this is how everything is organized in this dataset. So if we go back to our dataset, we have a train dataset, and also we have a validation dataset, and also we have test dataset. So what we are going to do next is to demonstrate how to load one of the images and then display the annotations on top of those images. So let's start with a new and fresh Python file. So the purpose is to load one image with the annotations and display the bounding box around all the annotations. So we will start with the import the YOLO module from the ultralytics package, and then we will import OpenCV library and also import the YAML library. Then we will define the path to the image file that we will use for our object detection. Let's copy the full path for this image. Don't forget to change the direction of the slashes. Great. Now let's define the file path for our annotation file. Don't forget that annotation file is on the label subfolder and the suffix should be txt. Now let's define the path for our YAML file, which contains the dataset information. Particularly, we need the label names. So the file is on C dataset plain cards, and the name of the file is data.yaml. Now we will open the YAML file and load its contents into a dictionary. We will name this dictionary data. Now we will extract the label names from the loaded YAML data. Let's print it. Great, so these are all the categories that we are going to train and detect. Now we will read the image using OpenCV and also retrieve its dimensions. Next, let's open the annotation file and read its lines. Each line contains information about one object in the image. Now we will process each of those lines. We will process each line in the annotation file. And now we are converting the bounding box coordinate from string to floats. And we will insert it into our annotation list. And let's print the result. Now, as you can see, we have several annotations, and we will learn how to use it and display it on our image. So let's start with iterate over each annotation to draw the bounding boxes and labels on our image. So we are grabbing the label ID and all the coordinates and convert the label ID into the label name. Next, we are converting the coordinates to pixel coordinates. So now we will have the x1, y1, and x2 and y2 in order to draw a rectangle around our annotation, around our specific object. Great. Now we will draw a rectangle on our image using those pixel coordinates. We will use the OpenCV rectangle function. As you can see, we are sending several arguments like the image, the position of the rectangle, the color, and how thick is the rectangle. Now let's also display the label name above our bounding box. So we will use the putText function from OpenCV library. We are sending the image, of course, the same image, the label name, the position of the text with 5 pixels above the bounding box, the font, and once again the color and how thick should be the font. Now we will use the IamShow in order to display our image, and we will add a wait key that waits for a keystroke. And let's run it. Great, as you can see, this is our image with all the annotations. So now we are ready to continue to the next step, which is training our model. Let's create a new Python file. Let's name it step number 4, train.py. We will start with import the Yolo module from the ultralytics package. Then we will define the main function, which will encapsulate the entire model training process. We will load the Yolo model configuration from our specific YAML file, and this configuration contains all the model architecture. We will choose the 8N, which is the nano model, the smallest one. Next, we define the path for our dataset configuration YAML file. This file contains all the information about our dataset, including the label names, path, and images and annotations. Next, we will define the project directory where all the training results will be saved. Next, we will define the experiment for the training session. And next, we will set the batch size for the training. This determines the number of images processed in each training step. And now this is the train of the Yolo model using the specified parameters. Data is the path for our YAML files. Epochs is the number of training epochs. One epoch means one full cycle through the entire training dataset. The project is the directory where the training result will be stored. Name is the subdirectory name within the project directory for this training session. Batch is the batch size for the training. Device is the index of our GPU for use for this training. 0 means the first GPU. Patience is the number of epochs with no improvement after which training will be stopped early. Image size is the size to which the training images will be resized. Verbose, if it's true, which in our sample is true, detailed login information will be printed during the training. Val equals true is that the model will be evaluated on the validation set after each epoch. So I believe that now we are ready to run our training. The results, including the trained model and logs, will be saved in this specific project directory with the experiment name. Let's fix this one, YOLOv8 and we are ready to run the model. So let's see the results. First of all, it loads all the trained images. As you can see, 21,000 images. Next, it will load all the validation images. It's about 2,000 images, and now it's starting the training. As you can see, this is epoch number 1, and let's wait a few more seconds just to see that everything goes with no error or problems. This is epoch number 2. Seems okay. As you can see, we are expecting that the box loss and the classes loss, the value should go down during each of those epochs. let's wait a few more seconds. If everything is going okay, I will stop recording and we will be back after the last epoch. Great. So we will be back after the last epoch and continue the lesson. So the training has finished, and we can see here the results for each of those classes. And let's go for the results folder. So here we are on the playing cards subfolder, and as you can see, the model has created a new subfolder named My Card Model. The name was generated by using those variables, the project, which is the folder, and the experiment, which is where it stores all the results. And let's go inside, and here we can find first of all the results PNG. Let's open the results PNG, and as you can see, the train goes down, and this is a good sign that our model trains very well. And if we look at the metrics of the precision, and here in this diagram as well, we can see that it goes up. This is another sign of a good training. And the results are stored here in this subfolder named weights, and if we open it, we can see that we have two files. One is the last epoch after the training, named last.pt, and another one named best.pt that contains the best weights of the training. Another important thing is to open one of those validation images. For example, if we open this one, validation batch 0, which is during the training, he runs the results on a fresh image from the validation. And let's open one of those images, and as you can see, if for example I will zoom here, you can see that in this card it trained with a precision of 0.9, that this is a 7 heart. You can see 7H, and if I go here, you can see that is predicted here is as a card with the value of 3S. S is the sign for the black heart, and the precision is 0.8. And in this, you can see once again, it's 8H8 heart with a precision of 0.8. This is another sign that our training is a good training. So next it will be test our model on one of those test images. So now we are on the final step, which is testing our model with a new and fresh image. So let's create another Python file. Let's name it step number 5, predict.py. We will start with importing the Yolo module from the ultralytics package. Also we will import OpenCV and OS. Now let's define the path to the test image. Let's choose one of those images from the test subfolder, and let's copy the full path for this image. Let's also copy the annotation of this image. This is relevant only for comparing the results of the prediction with the ground truth. Now let's read the test image using OpenCV. And let's also grab the dimension of this image. Now let's make a copy of the image for the prediction visualization. And now we will define the path for the trained model's weights file, so we can copy it from our previous Python code. So we will create a variable that is basically a join of the full path to our weights file. And our weights file is named as best.pt. Now let's load the trained YOLO model from the weights file, and let's set the confidence threshold for predictions. Only predictions with the confidence score above this threshold will be considered. Now let's perform the detection, and let's print the results. As you can see, the results contains a lot of data, like the name of the labels and all the predicted objects inside our image. Now let's learn how to extract this information from these results variables. So let's create a for loop that will iterate over each detected object data, and we will extract the coordinates x1, y1, x2, y2, and also the predicted score and the class ID. Then we will draw a bounding box and labels and the label for object with a confidence score above our threshold. So once again, we will use the rectangle function, and we will use the img predict, the copy of the original image, send all the coordinates, the name of the object, we will convert it from class ID to class name, and also we will choose a color for the rectangle. We will do the same for the text of the class. Great. Now the next step will be creating another copy of our original image, and we will use this image copy for the ground truth visualization. So let's create a new variable named img truth, and this variable will be once again a copy of our original test image. But now, in order to draw all the bounding box, we will get our annotation file. We will open this annotation file and read its lines. Basically, we've done it before with step number 3, so we just have to copy the same code and do some adjustments to our step number 5 Python code. As you can see, we are fixing the conversion of the label names, because we are grabbing the names out of our model. And I believe that we have to fix also the rectangle and the put text. It should be on our img truth instead of img. Great. And now we would like to display our ground truth image with the bounding box and labels, and the same for the predicted image. And let's also add the original image without any annotations. It should be results.names. Great. Now let's run it. So we have 3 images. On the left side is the prediction, on the right side is the ground truth. As you can see, it's a perfect prediction. Thank you very much. I hope you enjoyed this tutorial. You are most welcome to subscribe my channel. I will upload more tutorials soon. Bye bye.